Alright guys, today we're going to look at graphing nonlinear equations, specifically how to do it by hand without a calculator. Even if you know how to do it with a calculator, it's always great to kind of have an understanding of this so you can be more precise and accurate with your graphing, and also so you can interpret what you do get from a calculator when you graph. But I'm looking at a fairly simple nonlinear equation. Nonlinear equations are any equations that are not going to graph as a straight line. Everything from absolute value, exponential functions, trig functions, things like that. And they all basically, with this idea, work exactly the same way. This method I'm going to show you will actually even work for linear functions as well, but there are other easier ways to do that. So looking at a nonlinear function like y equals x squared minus 3, the idea here is pretty simple. What we're going to do is we're going to make a table. Kind of looks like this. And the table, the whole purpose of that is we're going to plug in inputs in the place of our x, and we're going to generate outputs in the form of y. And so, for example, plugging in something like -3 in the place of x, I would plug that into my equation, -3 squared minus 3, and that, of course, is going to yield 6. And so 6 would be my y. And what I'm going to do is I'm just going to repeat that process. I'm going to do it multiple times with like a -2, -2 squared minus 3, y is going to equal 1, and I think you're starting to get the trend here. If you plug in 0, you're going to get -3, and again, you could work through each one of these by hand. If you plug in 2, you're going to get 1. If you plug in, let's see, 3, you're going to get 6, and you kind of go from there. You can do this. I recommend with nonlinear functions 5 or 6 points minimum. The more points you take the time to do, the more accurate it's going to be. And so basically what happens is each of these xy pairs becomes a graphable point. So -3, 6. So going back to my graph, I'm going to count -3, 1, 2, 3, and then +6, 1, 2, 3, 4, 5, 6 here. Okay, so there's -3, 6 on my graph. And I meant to do that in red, so I'll make it red. There we go. Then coming back over, -2, +1, -2, +1. Okay, and then same thing, 0, -3, 0, -3 is right there. And then 2, +1 would be right here. 3, +6 would be here. Like I said, I recommend 5 to 6 points, just depending kind of on what your nonlinear equation is going to shape like. And then once you finish that, you're just simply going to connect your points. I know that exponential functions like this are going to be a U-shape, a parabola, and so they come up and look like this right here. And so this is a rough sketch of your nonlinear equation, y equals x squared minus 3.